Hi, in this video I would like to demonstrate classifying images of handwritten digits as their corresponding digits. You will require at least a basic understanding of Python to follow this demonstration. I will be using support vector machines for the classification. The method used here can be generalized to include cases where there are sets of data that can be classified in exclusive categories. For instance, classifying whether to buy or sell some stock based on a set of market conditions, or whether a patient has a certain type of cancer or not, based on an acquired set of diagnostic features. As you will see, classification using support vector machines is rather straightforward. We will need to obtain plenty of sets of data of images and corresponding labels for our demonstration. Thankfully, there is a well-known archive of this data called the Modified National Institutes of Standards and Technology Database, the MNIST database. The dataset I am using was obtained from the website I have shown in the description box. We will use an instance of a support vector machine classification class, an SVC object for fitting. The scikit-learn library already has a predefined class. Download it from the website in the description and follow the recommendations offered by maintainers of the library. I primarily use Ubuntu, so I can download it easily using apt-get by installing scikit-learn for the version of Python I am using. I obtained the data from the SVC file using the pandas library. I used the read_csv function, passing the file name as my argument. In order to test our system, we will need a second set of images and corresponding labels. This is often called the validation set, as opposed to the training set, and is the data set used for the primary classification work. There are preset functions within the scikit-learn library that can do this automatically. I have opted to create a loop that will probabilistically populate the training and validation sets. I use the random function in the random library and populate the two sets accordingly. We also need to reduce the number of test cases we are handling for our training. Later, when we are trying some different options provided by the SVC class, we will need to iterate through the function several times over. And if we use the entirety of the dataset, we may end up waiting for several minutes for each iteration. Therefore, I have opted to use only about 15% of the dataset. Okay, let's have a look at one data point before we continue. We will use pyplot to achieve this. Pyplot is found within the matplotlib library. We are looking at the first set of numbers in the array corresponding to the first image. The image is represented by a grayscale, and thus this array contains values from 0 to 255. The array is reshaped into a 28 by 28 matrix of integers, and we use the imshow function within the pyplot library to display the array. Again, since we are dealing with 8-bit grayscale images, you have to pass the argument cmap equals gray, and then set pyplot to show the image, and voila. The next step is surprisingly easy, since we are using training algorithms that have already been developed by the scikit-learn team. So we create an object that is an instance of the SVC class and pass arguments based on the type of the training kernel you want to use. In their most fundamental sense, think of these things as different methods to achieve the classification, some being more accurate but at the same time requiring more resources in order to compute. For now, we can get the classification algorithm working, and then later we will try and understand some of the more fundamental aspects of support vector machines. We need to confirm that what we did actually worked. We already have the validation datasets set aside. We will need to use the score function of the SVC class and pass the images and label arrays that we have set aside as the arguments. And then we'll just fancy up the output to show us just how accurate we are. So we are about 80% accurate, which is okay, but I think we can do better. First, let's try to simplify the data. Instead of dealing with grayscale images, let's make the images black and white and see what that does for us. Surprisingly, this improves the fitting by almost 10%. Changing parameters of the SVC object can also improve this a bit further. For instance, by changing the C and gamma values, like so, we can increase the accuracy even further to about 97%. We may wish to predict a new set of values from a given set of image data. To do this, we will use the predict function of the SVC class and pass the dataset we want to use as the argument. For now, let's use the validated image data that we have stored before and assume we do not have the corresponding labels. After this, create a file using the open function, passing the file name and the read-write state of the files as arguments. Then we will iterate through the predicted values array and write each value into the file we create. Lastly, we close the file. In this video, we have gone through a classification using support vector machines. I hope you have learned something worthwhile. Thank you for your audience.